This is SANAL from Physics Login. Today we are going to solve this question. Consider an ideal atomic gas confined in an isolated closed chamber. So it's a diatomic gas and the gas undergoes adiabatic expansion. Okay, so adiabatic process, these two things you can catch from here. Its volume gets doubled, volume changes there. So volume gets doubled. And the mean collision time between the molecules changes from tau1 to tau2. Okay, mean free. The collision time is changing from tau1 to tau2. Then you need to find out the ratio and find a value for x. This is the question. Okay. So mean free path and the mean free time means if a molecule is colliding with another molecule, so you consider the distance before the successive collision. So that is taken as lambda. This is mean free path. And time taken between these two successive collision, time is taken as tau, which is mean free time. Okay, mean free time. So how will you find out tau? Tau is the time is equal to displacement by velocity, right? So lambda upon Vrms. So Vrms, you have the equation, you know that Vrms equation, root of 3 RT by M, right? Molar mass is there, this M is molar mass. And when you check this one, lambda, we will check first, okay? Lambda is equal to what? Length, actually, length of the path during T time, during tau time, okay? So that length you have to calculate and divided by, if you divide this with the number of collisions in T times. So you're getting this one. So this derivation is there. Derivation, if you want the derivation, you can comment below. I can make a video on that also. The lambda will be equal to V into T upon pi d square, where d is the diameter, okay, diameter of the molecule, into Vt into N upon V. Okay, this is the formula. So this is equal to, when you calculate that Vt and Vt will get cancelled, it is 1 by pi d square N upon V. Number of molecules per volume, okay? N upon V. D is the diameter of the molecules. So when you combine this equation, what is tau here? Tau you will get it as lambda is 1 by pi d square N upon V into URMS value root of 3 RT upon M. From this equation, you can clearly see that we will go to the numerator. Tau is proportional to V and it is inversely proportional to root of T. You come from this equation, you will get this relation, okay? So now you got the relation of tau with the velocity and temperature. Then second one, that is that it is an adiabatic process. Adiabatic, for adiabatic process. For adiabatic process, you need to take the relation between temperature and volume because temperature and volume is changing here. So you can say that T V to the power gamma minus 1 is a constant. It is a constant, right? This is the relation, this you need to recall. And from here, you can say that the T will be equal to a constant upon V minus V to the power gamma minus 1, right? So you have one relation here. This is first. You can use this relation because you need to get the change with the relaxation time with the change in volume. So you can substitute this T value in this and you can check what is the relation. So tau is proportional to V upon root of, instead of T, you will put this value, K divided by V to the power gamma minus 1. So you can simplify what will be the relation v to the power 1 into v to the power gamma minus 1 into 1 by 2, right? So you can substitute this value, solve it. Tau is proportional to v to the power 1 plus gamma by 2 minus 1 by 2. So it will be 2 minus 1. So 1 plus, okay. V to the power 1 plus gamma 1, 2. So this is the tau relation with the volume. Then you can say that tau is equal to a constant into v to the power 1 plus gamma by 2, right? So you can write the two situations now. Tau 1 will be equal to k into v1 to the power 1 plus gamma upon 2. So tau 2 will be equal to k into v2 to the power 1 plus gamma by 2. You take the ratio now. Tau 1 by tau 2 equal to v1 by v2 to the power 1 plus gamma, right? So here you can see that this will be equal to, there is a change in volume. What happens? The V2 will become double, right? The gas, the volume of expansion, it is getting doubled. So you can substitute that value here. Tau 1 by tau 2 is equal to V1 by 2 times V1 to the power 1 plus gamma by 2, right? 1 plus gamma by 2. So this will be 2. So tau 1 by tau 2 is equal to 1 by 2 to the power. So 1 plus gamma by 2. What is gamma? Here it is given as, it's a diatomic gas, right? The gamma value, isentropic expansion constant will be 1.4. Okay, you need to memorize that one. 1 plus 1.4 upon 2. So this will be equal to 1 by 2 to the power. What is this value? So it will be 1.2, right? 2.4 divided by 2, 1.2. So your question, you compare the question now, you need to find out x value. Tau 1 by tau 2 is equal to 1 by 2 into x. So x value you are getting as 1.2. X is equal to 1.2. So if you find that this video